12.3 Energy intake and energy expenditure. Energy is used by the body to stay alive because you need energy to respire for all bodily functions, even when you're asleep. You need energy to grow and stay warm and stay alive. It is consumed through either food or drink. It is measured in kilocalories and kilojoules, but is usually just called calories and joules. Calories are actually a really small measurement, and there are thousands of calories in every kilocalorie. When you hear people talking about calories and food, they're actually talking about kilocalories. Scientists tend to use joules as a measurement, ordinary people tend to talk about calories. They are both a measurement of energy. The main and best source of energy for the body is carbohydrate, which releases 4 kilocalories per gram of carbohydrate. This is the best source of energy for the body because it is easy to break down and gives a good amount of energy per gram of carbohydrate. It's the primary source for fuel for exercising. Protein is used to repair damaged muscle tissue, so it is not used as the main fuel during exercise. It releases the same amount of energy per gram as carbohydrates, but it's more difficult to use as an energy source because it doesn't break down as easily. Fat provides 9 kilocalories per gram, which is more than carbohydrates and protein, but the body will not choose to use fat as a fuel source because it takes a very long time to break down and release energy. Bioelectrical impedance analysis is where an electrical current is sent through the body to work out the percentage of fat. The impulse is conducted very well through liquids such as blood and fluid, but is slowed down by fat and bone. BIA estimates the percentage of water in the body and does an equation to work out the percentage of fat. It can be measured by special weighing scales, a monitor which you hold, or with electrodes. The advantages of using biomechanical impedance analysis is that it's easy to work and you don't need training to use it. Also, it's really simple and quick to perform and can be used at home. The disadvantages of using biomechanical impedance analysis is that the equipment is relatively expensive, starting at £80 and going up to thousands of pounds. Skin fold analysis is another method of measuring body fat. The tester uses a skin fold caliper to measure the fat at 9 different points on the body, which are the bicep, tricep, subscapular, thigh, iliac crest, abdominals, chest, and the calf. The tester lifts the skin at each of these points, but they need to make sure they don't lift the muscle as well. The caliper needs to be 1 centimeter below the skin. The advantage of this method is that the calipers are cheap and they are widely used, so there's lots of data to use for comparison. Also, this method of testing body composition is a lot more simple and easy than using other methods. If you have a good understanding of how it works, it can be extremely accurate. The disadvantage of the test is that the person measuring needs to have a good understanding of where and how to measure, otherwise the measurement will be inaccurate. Also, this test is an invasion into people's personal space. If you're helping somebody who has a weight problem, this test might be upsetting for them. Hydrostatic weighing is weighing someone underwater to find out their body composition. It works because muscle sinks and fat floats, so a person with more fat will be more buoyant and weigh less underwater. Someone who has more muscle will weigh more and be less buoyant. First, the person needs to be weighed on land. They will then get into a tank filled with water and sit on special scales. They will then be lowered and asked to expel all the air in their lungs. The advantages of this test is that it's thought to be the gold standard of measuring body composition because it's the most accurate. The disadvantage is that the equipment is very expensive and is either found in universities or research institutions. It's mainly available for athletes rather than the general public. BMR is worked out by including information such as age, gender, height, and weight. The way in which you calculate BMR is worked out by the following equation. For women, it's 655 plus 9.6 times weight in kilos plus 1.8 times height in centimeters minus 4.7 times age in years. And for men, it's 66 plus 13.7 times weight in kilos plus 5 times height in centimeters minus 6.8 times age in years. So if I was to calculate my BMR, I would do the equation 66 plus 13.7 times 70 kilograms plus 5 times 182 centimeters minus 6.8 times 17, which gives 1819.4. But you can find out your BMR more quickly from calculators online. A person's age will affect their BMR because teenagers are growing, so they need more calories to support their growth compared to an adult who has finished growing. Also, as you get older, your muscle mass decreases, which slows down your metabolism because you don't need as many calories to power your muscles. Women have 5 to 10% lower metabolism than men because men have more muscle mass, so they burn calories more quickly because their muscles need energy to create contractions. Even if women are the same height and weight as men, they will still burn less calories than their male counterparts. Climate can cause the body to burn more calories. If external temperatures are cold, then the body will burn more calories because it will need energy to stay warm. Activity levels affect metabolism because if you're more active, then you'll need more calories to fuel your muscles. For instance, a competitive swimmer will need a lot more calories than a competitive golfer. For someone losing weight, it would be really useful to do exercise because the more lean muscle mass you have, the higher your BMR. By converting fat into muscle mass, you will burn more calories and lose weight. MET stands for Metabolic Equivalent Task, which measures how much oxygen you consume in relation to your body weight. It can be used with BMR to estimate how much energy the body consumes per day. BMR is useful, but only measures calorie expenditure at rest. Using both gives a more accurate amount of calories a person will burn a day. For instance, a swimmer will train for 4 hours a day sometimes, which means they will be consuming more oxygen because they are exercising. If they combine their BMR and MET, then they can work out their total calorie expenditure. Energy intake is the amount of calories you consume, and energy output is the amount of calories you burn. There are 3 scales, which are weight gain, weight loss, and weight maintenance. As you can see in the graph, if energy intake is greater than energy expenditure, then a person will gain weight. If energy intake is less than energy expenditure, then a person will lose weight. And if energy intake and energy expenditure are equal, then a person will maintain their weight. For the average sedentary individual, 50% of their diet should be made up of carbohydrates. They should consume 12 to 15% of protein and 30 to 35% of fats to maintain a healthy diet. By measuring the heat we produce during exercise, we can work out how many calories we are using. This is because the energy we have used has been converted into the heat we expel. So by measuring the heat we expel, we're able to work out how many calories we've used. Direct calorimetry measures the actual amount of heat produced by the body. An athlete is put in an airtight chamber with a mouthpiece so they can breathe. As they exercise, they produce heat. This heat rises and warms up the water which is circulating in the coils in the ceiling. By taking the temperature of the water, you can measure how much heat is being produced by the athlete and therefore how much energy they are using. The advantages of direct calorimetry is that it's referred to as the gold standard of measuring energy expenditure, and it's very useful in elite sport to get very accurate readings. The disadvantages is that it's very expensive and you need a qualified scientist to conduct the test. Indirect calorimetry estimates heat production by measuring respiratory gases using a Douglas bag collection and gas analysis system. If 1 litre of oxygen is consumed, then 4.8 calories are expended. By working out how much oxygen is consumed, you can work out how much energy has been used. The advantage of this piece of equipment is that it can be used by nutritionists to find out the exact calorie requirements of their clients. It can be used in real-life situations to help people manage their weight. The disadvantages would be that it's still quite expensive and is not widely accessible for most people. Body mass affects the amount of calories you need to consume in order to exercise. The amount of joules required for exercise is worked out by the two equations. Force equals kilograms in body weight multiplied by 10. Work equals force times distance. If Michael Phelps weighed 90 kilograms and swam 200 meters butterfly, then he would need 180 kilojoules to sustain his race. Force equals 90 kilograms times 10, which equals 900 kilograms. Work equals 900 kilograms times 200 meters equals 180,000 joules, or 180 kilojoules. I can apply the effects of energy balance on my own sports performance as a competitive athlete. I swim 16 hours a week and do 3 hours in the gym every week. I'm 17 years old, but I'm still growing. This means that my BMI is high because my body needs lots of energy to grow. Also, because I'm a boy, my BMI is 5 to 10% higher than if I was a 17-year-old girl. Climate does not affect my BMR because I'm in an environment where the temperature is regulated and remains stable. The number of calories I need per day is 1,819.4 at rest, plus I do on average 3 hours of high intensity exercise, for which is needed 588 kilocalories per hour, which means another 1,764 kilocalories, which means I need a total of 3,583.4 calories per day. In order to consume enough calories, I eat lots of carbohydrates. I have porridge in the mornings before training because it's a complex carbohydrate and gives me long-lasting energy. I eat lots of bananas, pasta, rice, and potatoes. After training, I always eat protein and carbs on the way home because it will help repair my damaged muscles. I have to make sure I consume enough calories because otherwise I lose weight. I also have fat in order to add calories to my diet, such as chocolate.